All right, thank you everybody for coming. Going to kick it off now with Scott to give some introductions.
All right. Thanks everybody for joining the webinar today. We'll be presenting on dynamic line ratings. Quick overview of the agenda for today. We'll go through introductions in just a minute, but part of the presentation today, we're going to start out after introductions with Kristine, who will be providing a technical presentation on dynamic line rating technology. She'll cover a lot about how it works and where it creates value for grid owners and operators. From there, we'll go into a section with Hilary to provide a presentation on regulatory action, specifically around the recent ANOPR, or Advanced Notice of Proposed Rulemaking. And lastly, we'll spend a bulk of our time with a Q&A. This will include questions from you, the audience, so please use the chat Q&A function within Teams, send your questions in. We'll do our best to address those during that section of the presentation. So starting with introductions. So I'm Scott Finnesand, Director for the Transmission Distribution Business Unit at Ulteig. 15 years of total industry experience, primarily working for electric utilities, delivering overhead transmission line projects, 69 kV through 500 kV across the US. My experience includes full project lifecycle, things from conceptual project planning, estimating, design through construction development and packages, as well as supporting asset management on transmission systems. Particularly enjoy exploring new technologies to make the grid more reliable, resilient, and integrated, particularly with where our system's at today and the need to address both load growth and new generation coming online as part of the energy transition, which includes solutions such as DLR. So I'm excited to be part of this webinar with some of the great folks from LineVision. Ulteig, for those of you who don't know who Ulteig is, we're a leader in the engineering and consulting industry, been around for 80 years, serve 4 primary lifeline sectors: power, renewables, transportation, and water. So I have a large team with planners, engineers, project managers with experience with power utilities and transmission lines. So again, thanks for attending the presentation. Thanks for your interest. I'll pass it over to LineVision and Kristine for her introduction.
Thanks for kicking us off, Scott. Hi, everyone. I'm very glad to be here today. My name is Kristine Engel. I'm here on behalf of LineVision. I have about 10 years of experience in the energy and utility industry, starting early on with field engineering in oil and gas. After that, I worked in consulting, specifically transmission line design. And the last 4 years I've spent at LineVision. So I lead our solutions engineering team here, which means that I get to work very closely with both our customers and our internal technical teams. My team is heavily involved in the early stages where we're helping everyone get comfortable with the technology, make sure we have a good shared understanding of how it works and where it can be most impactful. So really identifying those use cases, doing analysis on specific transmission lines to make sure that we're targeting the right spots, and then going through the project planning phases prior to handing off to our operations team. Typically, my team will come back in after our data delivery as well to help with analysis, whether that's just assessing statistics around capacity or thinking about how to use dynamic line ratings in operations, but also using the other data sets that are associated with our offering around situational awareness and conductor asset health. Hilary?
Sure. Thanks. Good afternoon, everyone. It's wonderful to be here. Thanks for joining us today. My name is Hilary Pearson. I'm our Vice President of Policy and External Affairs at LineVision. I've been working on energy policy for 20 years. In a few different sectors. So the public sector, I worked in the solar industry, worked in the utility industry, and I've been at LineVision for almost 3 years here in the grid enhancing technology space. So my team here at LineVision, we work quite a bit with industry associations and policymakers and other stakeholders to help educate and advocate for the use of grid enhancing technologies like dynamic line ratings, who, again, we think are a key tool in the toolbox to address many of the challenges that our grid and system operators are facing today. So we talk with a lot of folks all over the country, also different parts of the world, because again, I think the interest and the application for the use of GETS and DLR is pretty universal. So it's wonderful to be here.
Great. Thanks, Hilary. With that, I will jump into our technical overview of dynamic line ratings. So I'll be talking a little bit about methodology here, touching on kind of key use cases. There will be lots of opportunity for Q&A following Hilary's presentation, though. So please do share your questions in the chat as we go. Next slide, please. Thanks. So this is an overview of LineVision's dynamic line rating offering, really our entire platform, which is all powered by one set of hardware. This is hardware that we use for each of the applications that we offer. Really, a lot of the work that our team does is on the data science side. However, this is enabled by measurements that come in from the sensors. So the hardware is a critical part of that panel. Our devices communicate with cellular networks, and the power budget is designed for each project prior to installation. Typically, we install one sensor every 2 to 3 miles. This will vary depending on the complexity of the line construction, the complexity of the terrain. Typically, when you have a change in line heading, for instance, the wind is going to impact the first section differently than it will impact the section after that angle. So often that will trigger the addition of a sensor. Our solution is tower mounted, or structure mounted, I should say. We're agnostic to structure type. It's not installed on the conductor, so that means very importantly that no outage is required, no live line work is required, and we're able to monitor different types of conductors, any voltage level. We're not limited by things like the diameter of the conductor. Next slide, please. Great. So this is an overview really of a line rating methodology. There's a focus on dynamic line ratings on this slide and of course in our webinar today. However, when you think about a line rating calculation, you're really just balancing the heating and cooling components on that line. On the heating side, resistive heating due to the current flowing on the conductor will cause it to heat up, as well as solar irradiance from the sun. And then on the cooling side, we have radiative cooling that occurs because of the differential between the ambient temperature and the conductor temperature, as well as convective cooling from the wind. That convective cooling piece is really, really important for the line rating calculation. It also is one of the hardest variables to nail down since wind can vary over short distances and short times. So when I get into the methodology next, you'll see that a lot of the work that we do is really around understanding wind speeds, specifically within the transmission corridor. And that corridor might be quite narrow, it might be sheltered by trees or other vegetation, could be sheltered by terrain features, and those wind conditions across the entire line can change pretty dramatically. We use the IEEE 738 heat balance equation for running our line rating calculation. And very importantly, we manage the uncertainty that is inherent to any measurement that you take, but we manage uncertainty variable by variable using a Monte Carlo simulation. So when we're defining the wind speed input to the line rating calculation, for instance, we're using not only the actual reported measurement of that wind speed, but also an uncertainty around that for a distribution. That ultimately gives us a dynamic line rating at the 50th percentile, the most likely value, but that's paired with a confidence interval. So we have tools as well to assess things like what does a certain percentile selection mean for your conductor temperatures? If you were to operate at that level the entire time, would you have an exceedance of the maximum operating temperature? How severe would that be? How long would it last? And we can compare that really against the existing rating methodology, whether that's static ratings or ambient adjusted ratings. There is, of course, going to be some risk inherent to those static or ambient adjusted rating methodologies because wind is sometimes quite low. And we do see that with dynamic line ratings as well. Next slide, please. A question I get fairly often is, how do each of these heating and cooling components affect the line rating? And so this is a really nice example from NOAA that illustrates the relative impact of each of them. On the right side, you can see ambient temperature in the upper left, solar flux upper right, wind speed, and then wind direction down at the bottom. On the x-axis of each of these charts, we have a range of values that is typical or kind of within the realm of possibility. And so you can see over this range of expected values for each variable, how much of an impact does that have on the line rating? You can see, for instance, with ambient temperature and solar flux, the impact is relatively small. That doesn't mean it's not meaningful. Hilary will be talking probably a bit about FERC 881 as well, which requires ambient adjusted ratings on transmission lines. And the impact of factoring in ambient temperature for your calculation can still give you a few percent increase, maybe up to 10%. But really the big benefit of dynamic line ratings comes in due to the wind speed. You can see that we're more than 10xing that impact as we go across a range of wind speeds that's used on this chart. So really illustrates that wind is the most impactful variable in this heat balance equation. Next slide, please. I've touched a bit on really the different rating methodologies that we see on this screen, but just wanted to share an example for context. The chart that's on this page is showing us different line rating methodologies. The line that goes straight across around 2000 amps is a static rating. Above that, we see a higher line rating that has some variation, but not too much variation. That is the ambient adjusted rating. And up top in blue, we have the dynamic line rating, where we're seeing a bit more variation, but also much more capacity on average. When we use a seasonal or a static or a seasonal static rating methodology, making assumptions about the ambient temperature across that entire year or across the season it applies to, as well as the wind speed. When we move up to ambient adjusted ratings, as is required by FERC 881, we are now varying the ambient temperature to get some additional benefit from having that actual information about the ambient temperature, but we're still using a fixed assumption of wind speed. And out of necessity, that's usually going to be a conservative value. CGRE recommends using 0 meters per second at night and from 0.4 to 0.5 meters per second during the day for ambient adjusted ratings in the absence of a detailed weather study on your system. So those numbers are set pretty low to make sure that you're not encountering periods where the capacity is overstated and you're at risk of overheating. And then finally, with dynamic line ratings, we have actual information about all of the conditions that will heat and cool a conductor, really providing the best visibility and ensuring the best reliability, the most accurate ratings to understand the true conditions at any given time.
Great. Thank you, Kristine. So again, thanks for joining us today, everybody. So thanks to Kristine's great presentation, we've heard about how line ratings are evolving from static and seasonal ratings to ambient adjusted ratings with FERC Order 881 to now the discussion and focus on dynamic line ratings. So as we hear about transmission line ratings, I always think it's helpful to level set on who actually uses them. So line ratings, transmission line ratings, they are used by reliability coordinators, transmission system operators, planning authorities, and transmission planners in both reliability and market models to ensure that flows on transmission lines do not increase risks of reliability events, of damage to power lines or equipment. So in other words, to make sure that lines don't get too hot. It looks like I'm seeing that we're having an issue with my camera, but hopefully looks like camera issues have been resolved, so I will keep going. So these line ratings are so important because they directly affect flows on electric power systems, and therefore they affect the price of electric power and the overall reliability of the grid. So as we understand transmission line ratings, it's also important to consider how the Federal Power Act tasks FERC, our federal regulator, with ensuring that wholesale rates are just and reasonable. And I think much of the reasoning behind Order 881 and the continued interest and potential action in regards to dynamic line ratings has to do with this connection between transmission line ratings and just and reasonable rates. So next slide, please. Okay, so as we fast forward to this ANOPR, or Advance Notice of Proposed Rulemaking, I do want to clarify that the information shared and discussed today is not or is not intended to be legal advice. So this is for general informational purposes only. But this ANOPR was released in June, so earlier this summer, and it was issued to build upon past actions on line ratings. So items such as Order 881, as well as a notice of inquiry, NOI, that was released back in February of 2022, and ultimately aims to explore potential reforms to further enhance transmission line rating accuracy and to ensure transparency for the implementation of these line ratings, as well as congestion reporting practices. So considering the advancements in DLR technology, the information collected after the issuance of the NOI a few years ago, as well as subsequent outreach, FERC is essentially looking to assess whether transmission line ratings that do not account for forecasts of solar heating, wind speed, and wind direction accurately reflect actual conditions. So specifically, the proposal would mandate some specific DLR practices, such as number one, requiring transmission line ratings to reflect the impacts of solar heating by considering the sun's position and forecastable cloud cover. It would also require transmission line ratings to reflect forecasts of wind conditions on certain lines. And also, it would enhance data reporting practices related to congestion in the non-RTO ISO regions to help identify candidate transmission lines for the proposed wind requirements, which I will get into. So I'll start with the solar requirement. Regarding solar, FERC is proposing that all transmission line ratings used for evaluating near-term transmission service be subject to a solar requirement based on two factors. So the sun's position and up-to-date forecastable cloud cover. FERC preliminarily believes that the former can be achieved without sensors and is seeking comment if sensors are needed to achieve the latter. They're also seeking comment on the overall approach, including on the cloud cover forecast time horizon. This solar requirement would be required in day-ahead and real-time markets, but not required in point-to-point service in the RTO ISOs. There is a proposed exception, essentially where technical capabilities of the limiting conductor or equipment is not dependent on solar heating. The proposed timeline it would be 12 months after any final rule or order is issued. And as some context in regards to the solar component, the record in Order 881 indicated that considering solar heating based on the sun's position can affect a transmission line rating by as much as 5 to 11%. The ANOPR also noted some joint research and modeling done by Commission staff and NOAA, the federal agency, which found that considering hourly clear sky solar heating increased transmission line ratings. Again, this is relative to the daytime, nighttimes ratings approach, in each of the 4 hours immediately after sunrise and before sunset by 4 to 12%. So this discussion around solar also comes at a time where we're seeing widespread growing adoption of rooftop solar PV. This increase of rooftop solar is essentially shifting demand towards the later afternoon hours, creating something called the duck curve. The duck curve is the difference between solar power generation and electricity demand throughout the day. It gets its name from looking like a duck. So it dips in the middle of the day when solar production is very high, but energy use is low, and it rises significantly when folks come home from school or work and turn on all the appliances right when we see the sun starting to fade. So as demand is rising in this kind of late afternoon timeframe and the sun is setting, it's also when we generally see wind speeds rising, which can provide thermal cooling to transmission lines. So I think it's exciting to potentially see the use of DLR to help address some of these periods of peak demand on our system. So the wind requirement, Here, FERC is proposing to require certain transmission lines reflect up-to-date forecasts of wind conditions, including wind speed and direction, for use in 48-hour transmission service. Now, importantly, this wind requirement would only apply to lines where two things are happening. So number one, on lines that are exceeding thresholds for wind speed. So this would be proposed for lines where at least 75% of the line is in an area with historical average wind speeds of at least 3 meters per second, measured at 10 meters or about 30 feet above ground. And number two, lines that are experiencing congestion. So in RTO ISO regions, FERC is looking to determine a congestion threshold, including it should be adjusted annually. There were some comments in the NOI on potential congestion thresholds. You know, on one end, groups like the Watt Coalition working for advanced transmission technologies proposed a threshold of $500,000 of marked congestion in the past year. On the other end, on the higher end, PJM, the largest market operator, proposed a $2 million threshold. So in non-RTO ISO regions, FERC is proposing to develop a new proxy for congestion called a limiting element rate. This limiting element rate, or LER, would attempt to calculate the adverse impacts on transmission service when a line rating is the limiting element, and it would be a megawatt hour a year threshold. So again, lines would have to meet both of those criterias to be subject to this overall wind requirement. So if transmission lines that have no congestion or have congestion levels that are essentially below the proposed threshold, they would not be subject to any wind requirement, even if they meet the wind speed threshold. So for transmission providers with lines subject to the wind requirement, FERC is proposing to require that transmission providers apply the wind requirement to essentially 0.25% of their commission jurisdictional transmission lines. So this would be about 1 in 400. And in trying to contextualize that threshold, FERC is also looking for comment on approximately how many jurisdictional lines 0.25% represents, and how many transmission lines the average transmission provider actually operates. The wind requirement would be required in day-ahead and real-time markets and point-to-point and SEAMS transactions in the RTOs, ISOs. And the exception, oops, computer troubles here. Are folks still, sorry, had a computer issue, but the exception that's noted in the ANOPR is that on this wind requirement, FERC does propose to allow transmission providers to self-accept a transmission line from the wind requirement if it determines, consistent with good utility practice, that the transmission line rating is not affected by wind conditions, or that implementing the wind requirement on such a transmission line would not produce net benefits. So this could be a partially underground line, for example. And the proposed timeline from the final ruling would be 1 year to collect congestion data, then 6 months to implement on required lines. Thank you for shifting to the next slide. So as I noted, on congestion thresholds, FERC is seeking comment on this. They're also proposing to require transmission providers to post on OASIS a new congestion database associated with the ANOPR, such as the limiting element rate database, with a data retention of at least 5 years. Confidence levels are also mentioned in the ANOPR. FERC is seeking comment on whether they should establish a default confidence level that transmission providers are required to use when calculating line ratings subject to the solar or wind requirement. And then in regards to timing, this was issued earlier this summer and published in the Federal Register. So 90 days later, the timeline for initial comments is October 15th. Reply comments are due 30 days later, that's November 12th. Seeing this is an ANOPR, advance notice of proposed rulemaking, a next step after this could be a NOPR, notice of proposed rulemaking, a NOPR being a critical threshold in advance of FERC opting to issue any final order on this matter. The other thing just implied in this ANOPR is that any DLR measures would essentially occur after utilities have implemented and gained experience with AAR. And as just a reminder for folks that the 881 compliance deadline is July of 2025. So just about a year from now. So I think that's, love to open it up and answer any questions.
All right. Thanks, Kristine and Hilary, for the informative information. Now as we'll go into some Q&A from the audience, as well as some questions related to that frequently come up related to DLR. So I'll throw the first one out there as we're waiting for additional questions to come in from the group. So Kristine, this one's for you. I think thanks for going through all the mechanics and data that informs dynamic line rating systems. I think there's different solutions and approaches that generally are there to achieve the same result, monitoring and reporting on conductor temperature and position. But not all methodologies are the same. So what matters most and what sets different methods apart from each other when you're evaluating that?
Thanks for the question. Yeah, you're completely right. There are a lot of different ways you could build a dynamic line rating model. Based on our experience at LineVision with all of our past projects, for DLR specifically, field validation is really, really critical. We've observed wind speeds in the transmission corridor that are 30 to 120% of those wind speeds reported by regional weather providers in the past. And so what that means is that when you build out a line rating calculation using just weather data or a centerless solution, you're at very high risk of overstating those wind speeds a lot of the time. So the approach that we've really taken is to include conductor feedback as a validation method for these models that we're building. That's really, really critical to understand what is happening to the conductor's temperature, and is that lining up with our knowledge of the current conditions in the transmission corridor. So we measure seg, we derive conductor temperature from it based on CGRE 498, like I mentioned, and that's used ultimately for the validation to ensure a safe and accurate model.
All right, thank you for that. We'll go to the next one here. So utility operators historically have been operating on these static line ratings that have been out there historically for a long time. Basically, the transmission capacity doesn't change with temperature. We all know that's not true. You just presented on that, and they were operating on maybe 2 seasonal ratings, a winter and a summer, and a normal and emergency. This is changing how the grid is being operated. What challenges the adoption of DLR technology present to utility system operators in moving to this new methodology?
Yeah, I can comment on a couple of topics that I see come up in the discussions I'm having. One of those is just that a lot of systems aren't set up right now to manage hourly ratings, or they're not set up maybe to manage this 10-day forecast that's required by FERC 881. There may be some mirroring of that if there is dynamic line rating rulemaking in the future. Nobody knows that at this point. However, the EMS, like an energy management system, and even if you think about planning software, often can't handle the hourly ratings that dynamic line ratings provide. So that's one challenge, but I do feel like we're working through that as an industry as a whole when everybody is figuring out their 881 compliance, because even if you're just bringing in ambient temperature adjustments on an hourly basis, you must be able to handle those hourly updates along with the forecast. And then the other piece that I'd mention is on the security side. So we've worked through security questionnaires with many of our customers. We're working on integrations with a number of our customers and have a couple that are already live. And so each transmission owner will determine what is compliant for NERC SIP within their system. We do have an on-premise solution, though, that typically checks that box for most of our customers. So really important to think about what data is flowing into a dynamic line rating model and how it gets there. We tackle it by making sure the signal coming from the sensor is quite simple. It's really just a point cloud that we can then convert to the measurements that are meaningful for our modeling process. but we work with our customers to make sure that we're meeting all needs.
So I'd love to hop in and maybe try to flip that question around a little bit and just posit some thoughts around the benefits that we see DLR, helping to bring to operators. And I think accuracy, that is a critical benefit of this new data coming in from the field. It's being able to help demonstrate, what are these lines safely capable of carrying? What are they experiencing? How are they moving? And in the context of what is happening, that operators are trying to contend with, so increasing extreme weather events, we have uncertainties with load forecasts, being able to help get more data in. And yes, Kristine, the items that she mentioned are real, upgrading EMS systems. These are not necessarily super quick processes, but when we're able to get more data into them, it really does help to ultimately enable more informed decisions. I think we also know that we have kind of a gap today between what we're seeing by way of load growth, for example, and traditional infrastructure. So the use of DLR very much being an and solution, we know traditional infrastructure is critical, but we also know, again, just some of the timelines that come with that traditional infrastructure. So if we think about a data center, for example, from the time a data center is deemed certain to interconnect, it can typically do so in about 2 years. However, if new grid infrastructure is needed to accommodate that data center, that can often take 7 to 10 years. So if you can essentially use DLR to get 20, 30% more capacity, 90, 95% of the time, or just wait 7 to 10 years for that traditional solution. Again, the use of DLR, integrating the data, it helps to present some new options. Let's look at this data to help make the most informed choice, one that does prioritize safety and reliability of the grid, but also ensuring that the grid is able to continue to enable economic development opportunities associated with this load growth in what is just an increasingly digital economy.
Did we lose you?
I think we might have just lost Scott for a moment. Looks like
Okay,
he's
he's back.
rejoining.
The day of technical difficulties. I think I'm back. No, great responses, both Kristine and Hilary on that. As a transmission line engineer, real-time monitoring and knowing how your system is performing versus design, the world of digital twins is particularly important and interesting. Next question that we got from the audience here, transmission lines are very long linear assets. They can, go over many different geographies, canyons, different weather conditions, just as you were mentioned. So, a transmission line rating is going to be limited by maybe a single span related to how that line is performing. So when you have a long linear transmission line that's covering, several miles, how do those sensors communicate across those different spans? What if there is a big difference in wind speed that you're seeing, in one particular area versus another that maybe has some vegetation or tree coverage? And how does that inform operators to what is the true rating of that line and what it's safe to operate at?
Yeah, thanks for the question. I can take that one. So to start with the first question there, the sensors that we install don't communicate with each other. They don't need to. Each of them has cellular, like private LTE comms to send this basic point cloud data back to us, which we can then process and turn into something that is valuable and meaningful for the dynamic line rating model. So there's no reliance or interdependence on the sensors themselves. In terms of our project scoping process, when my team sorts out how many sensors do we need and where are we going to place those, we have guidelines around how how much of a change in the heading there is, around how far of a distance we're going, around how does the sheltering change as you go across that line. So we're really looking for sample points that help us identify or help us capture data at each unique section across the line. And we feed that validation into the DLR model. So ultimately, when we calculate a line rating, we're really calculating the rating of every single stringing section on that line, and we're reporting the minimum of all of those values as the actual line rating that would ultimately go into operations. And that limiting section is not always going to be the same. You'll often have trends where the wind trends might change day to night, or they might change across seasons and cause a different section of the line to be limiting at different points. And so really, when we have this set of sample points across the line, we're always going to report the lowest or the lowest rating that's coming out of those.
Oh, great. Thanks for that. Getting lots of good questions in from the audience, so keep those coming. Next one, I'm going to go to Hilary, really on policy. So you talked a lot about the ANOPR and some of the legislative changes in order to advance GETs and DLR in particular. So while DLR has proven to increase capacity for the grid in most cases, Kristine showed that. What policy or regulatory changes do we need to continue to see for utilities to increase adoption and see DLR as a real tool in the toolbox that they can deploy on their system, capitalize the costs, and really see the rate of return that they would in maybe some of these other infrastructure upgrades?
Sure. No, great question. So I think, from a federal level, I think it is really encouraging to see this ANOPR on dynamic line ratings kind of continuing this line ratings journey, so to speak. Also encouraging to see the consideration of dynamic line ratings in FERC Order 1920, which addresses regional transmission planning and cost allocation. But we've also seen the grid enhancing technologies, DLRs, highlighted in programs that are being funded through the bipartisan infrastructure law. So, for example, the GRIP initiative, showcases funding opportunities where use of DLR and grid enhancing technologies are available. So, helping showcase that these technologies help to support grid resilience and, have demonstrated technological benefits. So if that's on a federal side, I think what's been encouraging is to see the growing amount of state interest and activity on grid enhancing technologies. So whether that is, potential legislation that calls for a study of these technologies in a particular state, or, how can regulatory bodies review for these technologies, particularly in existing state planning processes. Just earlier this summer or late spring, I guess, there was also an event at the White House where there was the announcement of a federal state modern grid deployment initiative where 21 different states are essentially saying that they're going to be working collaboratively to modernize their grids. Part of that involves a public-private sector initiative to upgrade 100,000 miles of lines in the U.S. So I think that is encouraging. There is, I think it's a bit TBD in regards to what we see on incentives. There, is an open docket at FERC looking at transmission incentives. There's also been legislation introduced earlier this year called the Advancing Grid Enhancing Technologies Act, which would require FERC to establish what's called the shared savings incentive for grid enhancing technologies like DLR. But again, back to the state perspective as well, there's also the ability for states, when they look at their own particular footprint and state policy goals, how can they think about, what are specific outcomes by way of a performance-based regulatory model that we think are important, and, can the use of grid enhancing technologies and DLRs help support those outcomes? So I think we've seen about 17 states in the US that are looking at considering or implementing what's called performance-based rate making.
Well, thanks, Hilary. I think policy adoption in the industry really is what fuels some of the changes. So excited for some of that. Next question is for Kristine. Mentioned FERC 881 requirement of ambient adjusted rating, or AAR, and the fundamental kind of difference between what DLR provides. So is there any advantage for a line that, utilities are required to adopt AAR as part of FERC 881 coming up in 2025? DLR is maybe the next step in that. What's the difference between the two, and maybe how would a line be different with just DLR versus AAR, and kind of getting into that a little bit?
Yeah, thanks for the question. So the most obvious thing that comes to mind is the capacity increase you will see with ambient adjusted ratings, depending on how the rating methodology is set, and specifically the wind speed assumption, max operating temperature. We often see an increase that will likely cap out at max of about 10%. With DLR, we see capacity increases of up to 40% on average, since we're factoring in that wind speed component. In addition, though, to that capacity, there are also other benefits of having these data streams. So one I'd mention is situational awareness. Our system, of course, measures the sag of the monitored spans, and so we can report on those sag measurements. Our customers can set alerts if we're approaching a limit. And from that, we can also derive conductor temperatures and set the same kind of alerts if you want to see when you might be approaching the max operating temperature. So having that kind of information could really inform operational decisions that you might make if you're at kind of a pinch point or in a contingency scenario. The other benefit that I would mention is a lot of this data is valuable for assessment of conductor asset health as well. So this conductor temperature data specifically, we can use, and we do use for our customers, to evaluate annealing risk, or the risk of a strength reduction due to softening of the aluminum strands for conductors that have aluminum. And then separately, we can run an elongation analysis to compare where is our observed sag compared, and how does that compare to the expectation from the design data that we have.
Yeah, and maybe just to debunk a quick myth, I think this was shown pretty accurately in your slides from the technical presentation, but DLR is really the actual real-time measurement of the conductor. AARs, there's still a lot of assumptions that go in that. So while DLR majority of the time will provide capacity increases, it's not a guarantee, right? Because of some of the assumptions that are missing in that equation when you consider the differences.
Yeah, thank you for bringing that up. It is important to note, so even if your static rating methodology or your ambient adjusted rating methodology uses a very conservative wind speed, there are still going to be some periods of time when the true wind is lower. So even when the existing rating methodology is conservative, we still see the dynamic line ratings go below static or AAR some small percentage of the time, which you can look at and think, how am I going to manage this? But really, in my view, there's a huge benefit there in terms of accuracy of data and therefore system reliability and safety. Typically, those dips we see don't go too far below a static rating, for instance. The increases you see are going to be a lot greater than that. But it's still important to have those insights about when the ambient temperature may be as hot and the wind speed is also low, because that does really impact the capacity. And ultimately, we want to make sure we're not exceeding the maximum operating temperature or causing a clearance violation.
Yeah, great. Let's get back into another question around policy. So this one for Hilary. So FERC 881 just came out with their landmark ruling for quarter 1920 around long range transmission planning. You mentioned DLR as a tool in the toolbox. How does DLR fit into the equation when utilities look at addressing that order?
Sure, I'm happy to. So yeah, Order 1920. These are, newly approved rules from FERC requiring transmission owners to do sufficiently long-term, forward-looking, and comprehensive regional transmission planning, and to consider dynamic line ratings in that process. So at a high level, I think just due to the nature of compliance, the impact of Order 1920 is likely a few years out. But in the near term, I think, it's critical for utilities to look to start to operationalize dynamic line ratings. So when you use DLR in operations, you can create you'll get historical data sets of line ratings that can then be analyzed more granularly to help create probabilistic ratings that you can make available, look at from a seasonal, monthly, or a more granular level to help inform your planning process. So this additional data regarding the hourly thermal rating, can help to maximize the efficiency of transmission planning. And I think, at the end of the day, a more efficient, cost-effective transmission planning process, that really is what Order 1920 aspires to help create. And DLR can definitely help in that process, particularly when we think about, there are 7 identified economic and reliability benefits in the rule. So again, the use of DLR as a way to show progress towards production cost savings, for example, or reducing grid congestion, and helping to improve performance in extreme weather. Those are identified benefits identified in Order 1920. And lastly, I'll just throw in, I know there's a lot of questions around, how can these technologies be modeled, become part of the planning process. So I think Kristine called out earlier, critical to see these technologies in the planning and modeling software tools that help to inform these processes. And then I think there's a lot of important stakeholder groups working on creating guidebooks and technical applications on the use of these technologies, particularly in planning. So PJM, I think, is going to have some materials forthcoming. New York has an advanced technology working group where they're looking at DLR and a few other technologies. And then EPRI has also launched what's called a Get Set initiative, where I think, helpful materials will be forthcoming from that effort. I think we lost our moderator again.
I think we lost our moderator again. So
You're the moderator, George?
yeah. In the absence of Scott, there he is.
Sorry about that. I'm not sure what's going on. I think we have time for maybe one more question. So O&M costs are something that utilities are continuously monitoring and concerned with their capital budgets and spend and how it impacts their rate recovery structure. So what's the ongoing O&M cost look like for DLR and, particularly LineVision?
Yeah, thanks, Scott. I can take that one. First thing I'll mention is all of our projects to date have been fully capitalized. Typically, we issue contracts with a certain term length. And so within that contract, there's also a warranty for the full life of the contract, meaning LineVision is responsible for all of the monitoring, the diagnostics, and any replacements, like if we need a new battery in a device. We do have a field team who goes out to provide support, but we don't touch our customers' assets without their involvement, of course. So typically the crew from the utility or perhaps the contractor will be involved to do the actual work. But really all of the detection, the planning, and then the support on execution is provided by LineVision.
All right, I apologize. I know there's a lot more questions in the Q&A that we didn't have time to get to. I think given we're coming up on the top of the hour here, we'll go ahead and wrap. Encourage everybody to reach out to LineVision, reach out to Ulteig after the presentation for anything that we weren't able to answer. Hopefully you learned a few new things about dynamic line ratings. Finally, how do Ulteig and LineVision work together? I think this slide really sums it up. Best-in-class technology and engineering solutions. We talked a lot about how DLR has a place in the energy transition, changing energy needs with increasing capacity needs on the grid, enhanced reliability through situational awareness, real-time understanding of grid conditions, allowing for faster interconnections for both load growth as well as renewable generation. DLR can be implemented a lot faster than some of the other infrastructure upgrades. We're still going to need to build more transmission, better utilize existing corridors, but GETs and DLRs are one solution that can be deployed in a quicker, fast, and efficient manner. At Ulteig, we can support this process through our consulting and engineering expertise, really through that upfront transmission planning studies, those capacity evaluations, and comprehensive assessments to recommend where DLR installations make sense and can be a priority on your system, as well as our expertise all the way through the project lifecycle. We have experts in transmission line engineering using PLS CAD, project management, and even the policy team and state advocacy that we can provide. So again, if you're interested in discussing further, we'd welcome the opportunity to discuss further on where dynamic line ratings may make sense on your system. Our contact information is shown on the screen there. So make sure if you reach out, just reference the webinar so we can make sure the communication can be appropriately routed to this team, and we'll handle any questions that may come up. So thanks again for your interest and attendance at this webinar.